the reaction of alkanoic acid, we were checking at propanoid acid plus sodium hydroxide to get sodium propanoid. You replace H with sodium and water, a neutralization reaction, and it's balanced that way. Generally, when alkanoic acid reacts with alkali, you get alkanoid plus water. And the last, not the last, the other reaction is alkanoic acid plus a metal carbonate. We get salt plus water plus CO2. And the salt is from the metal in the carbonate, metal alkanoid. E.g., when you have ethanol, CH3, COH plus sodium carbonate, we get sodium ethanoate, that is CH3, COO sodium plus CO2 plus water. That is the reaction, but when you check, the equation is not balanced. There are 2 sodium this side, the other one, these are 2, 1, so we have a 2 there to balance, which affects the alkyl here. We also have a 2 there, and now the equation is balanced. They have aqueous, gas, and liquid, but the acid status are not compulsory in organic equation. And the last one is, which I won't repeat, the last one is the reaction of alkano is esterification. So we said there was property unique. Number 1, carboxylic acid are weak acids. Number 2, they react with a metal. Number 3, they react with sodium hydroxide. Number 4, they react with sodium carbonate. And number 5, esterification. We said this is butanol plus pentanoic acid. It's an ester, we get called butyl pentanoid plus water. I'm not repeating esterification, that is an ester. The last part is uses of alkanoic acid. Number 1, used as solvent. They are used as solvent. Alkanoic acid are used as solvent. Number 2, in manufacture of drugs and other chemicals. It is also used in flavoring food, to hand flavor in food. That is flavoring food. E.g., ethanoic acid, that is used as a vinegar. Ethanoic acid. Another use, manufacture of synthetic fibers. We make synthetic fibers, e.g., nylon and Dacron, and also in preservation. There's a difference between preservation and in flavoring. Preservation, we use benzoic acid, the one that sublimes. Those are uses of alkanoic acids. Uses of alkanoic acid. Those are mainly the uses of alkanoic acid. So, want to check, we have a part of organic chemistry too, which is a detergent. Very first, we check as detergent. What is a detergent? A detergent is any substance that improves cleaning of water. So when you use it with water, it improves the properties of cleaning of water. So we say it is any substance which improves cleaning of water. So you can't use detergent alone. You have to use it with what it improves cleaning. There are two classes of detergent, two types of detergent, that is soapy and soapless. There is soapy and soapless detergent. Two types of detergent, soapy and soapless. So you want to check out soapy detergent. How do you realize or know this one is a soapy detergent? The soapy detergent are also called soap. So when you go to and they say I want a soap, you only want a soapy detergent. They are also called soaps, and they are prepared using fat and oils. So we get soaps from fat and oils, and it is a sort of sodium and potassium. With a general formula of CnH2n plus 1, then COO replaced by sodium or potassium. This is the general formula of soap, whereby when I have C12, then soap will be H 12 times 2, 24, 25 CONA. So generally that is a soapy detergent. So we know fat and oils are esters. They are esters. They belong to a class of esters. And we say fats are found in animals naturally. You can get fat from animals, and oils from plant and some animals. So we say fat are found in the animals, but oil can be found in both plant and animals. So fat are found in animals, but oils are found both in plants and animals. They both get oils. So, for example, oils found in animals or plant. So we have oil, example, whale oil. Whale oil from whales. We have groundnut oil. We have corn oil. We have coconut oil. There are so many. Fat are also found from things like milk. So fat can be found in milk. These ones are found in milk. You can get it from land from pigs, that is lard from pigs, and also from some mallow animals. So we say fats are a saturated organic compound. So fats are saturated, while oils are unsaturated. They are unsaturated. Fat are saturated. Oils are unsaturated. The other step we want to know is how to prepare soap in the lab. Lab preparation of soap. How do we get a lab soap? All that. So we take oil. You take oil. It depends whichever oil. Maybe, for example, castor oil. Then when you take oil, you heat it together with sodium hydroxide. So you take a oil, mix with sodium hydroxide, and heat that mixture. When you heat this mixture to boiling on an evaporating dish, you of course you put them in an evaporating dish and you heat it on a water bath. Then when you heat, you stir. As you stir as you heat, and you hand some distilled water as you heat. So you heat those two and stir, and you hand distilled water. Now as heating continues, you hand sodium chloride, a few spatulas like 3, that is sodium chloride, you hand to the mixture you are boiling, and the purpose of this is salting out. It is salting out, to salt out. And the addition of sodium chloride in the mixture is to salt out. Salting out is reducing solubility. You reduce solubility of the soap. You reduce the solubility of the soap in the glycol. Yeah, so when you are eating, we say you eat fat plus an alkyl, sodium hydroxide, and you're going to get soap plus glycol. So we hand this glycol, it's why we are handing sodium chloride to salt out, to avoid soap to dissolve there. So I'm saying, when you are preparing soap, you take oil, you mix with sodium hydroxide and heat them. When you heat them, as you hand a little distilled water while you are heating, and then you hand sodium chloride to salt out. And the salting out is to reduce soap from dissolving in the glycol. Now allow this mixture to cool. You allow that mixture to cool and then filter. And the residue you have, you clean with distilled water is the soap. After you filtering, the residue is the soap. That is our soap. That is how we prepare our soap in the lab. So we are saying, when an alkali is bonded with oil or fat, the process is called hydrolysis. Hydrolysis takes place. This is hydrolysis. Hydrolysis takes place, and hydrolysis takes place, and we get soap plus a glycol. And this process is when a fatty acid or a fat is hydrolyzed in the presence of sodium chloride, then we refer this process as saponification. Saponification. When we hydrolyze fat using an alkali, the process is called saponification. And in the hydrolysis, a sodium hydroxide neutralizes the acid to form sodium salt of the acid. And when we add sodium chloride, remember we have seen this for salting out. You rinse the soap using distilled water to remove impurities and then glycols. This is an example of a soap. We have the alkyl group there, the fatty acid reacting with hydrolyzed by sodium hydroxide, the one we are calling saponification, and we are getting a sodium salt there and a glycol. So the sodium salt there is the soap. That is a soapy detergent with a hand of alkyl group. Now, the next part of our discussion today is we want to concentrate on how soap works. And soap got two ends. So, for example, when I have CH3, CH2, 16 plus COL, that's a soap. So it has two ends. This one we call polar, and this one we call it non-polar. And soap has two hands, soap molecule. The side with hydrocarbon chain, which is nonpolar, does not attract water. So we call it water-hating head, hydrophobic. The alkyl part is called hydrophobic. The carboxylate end, one with sodium and carboxyl group, carboxylate end, is called water-loving, and the name is hydrophilic. So soap got two ends, one hydrophobic, the end with alkyl group, and hydrophilic, the end with carboxylic group. So when we can also say it is RCOO sodium. So this end is hydrophilic, the alkyl group is hydrophobic. And now R, the alkyl group, we have said it is water eating, and the polar head is water loving. So the polar head dissolves in water. The polar head dissolves in water, while nonpolar head is oil soluble, attaches itself on the grease on whatever you're cleaning. So we are saying the nonpolar head carboxylic group is oil soluble, the hydrophobic, and dissolves in the oil or the dirt in your clothes or on grease, while the polar head is water soluble. So during washing, you agitate. Agitate is venye unafanyanga kutauta nguo hiyo, agitate. So when soap is added to water, the non-polar head, that is hydrophobic end, attaches itself, or we say launch. They launch themselves. We say this end launches themselves to the grease, and now the other sticks to water. This end will stick itself to water, and when you undo agitation of the material you are washing, the carboxylate ions that sticks on the grease particles dislodge, and launched itself. So after agitation igutauta, I don't know how you call it in your language, agitation, it dislodges itself with the grease from the cloth or the plate or whatever you're cleaning. So it dislodges itself, and then it forms droplets in the water, and they get out as micelles. And micelles do not come together because they repel one another. And to clean away micelles, you rinse. That's why we rinse our clothes after washing with soap. You rinse them to remove the micelles. So in this book we have this is the grease in the garment, and this is the detergent. So you realize it has two ends, the end that is polar and the one that is non-polar, the one that launches themselves to the garment. So when you do agitation, you realize you break these molecules, and the hands that attract to the garment or grease dislodges, and then you clean them as micelles. Now, what happens when you clean cloth with hand water? Hand water, remember we said hand water is a sort of magnesium and sodium that are soluble. In other ones, they contain calcium and magnesium ions. So that is hand water. When you hand soaked in this water, a precipitation reaction takes place. That is, an insoluble salt is formed, a precipitate is observed. The sodium salt here, this is the soap, since it's a soap, and there's calcium ions in the water. What happens is they are aqueous now here. They are in ion solution. They displace sodium in the soap and they form calcium ions attached to the alkyl group. So this substance with calcium is a solid, insoluble. That is our precipitate. And now sodium ions that were in the soap remained as ions in the water. So you realize and water will not lather easily until you precipitate all the calcium and magnesium. Until all of them are precipitated, and water is broken and made soft. Water soap cannot lather. And those precipitates are the ones that forms or float on water as scum.